Hey guys, and welcome to Functional Print Friday, and welcome back to my shop. So this was the cover for the vent that comes out from the range hood from our kitchen, and it exits into the ceiling or the soffit of the covered area of our porch that wraps around the house. I don't know, is that still a soffit if it's technically like a ceiling of the porch? Somebody probably knows better than I do and will let us know down in the comments. But anyway, we're clearly going to be working on this today. So I don't think there's any point in trying to fix the existing one. This looks like it is really quite brittle. Yeah, I'm not sure what this is. I'm going to guess ABS. And it's in two parts. There are some ribs on here. I don't know if originally that was meant to fit up inside of the mounting ring that is still up in the ceiling. And there's some foam in here. And the foam is kind of starting to break down too. I don't know how much of that is just exposure to the elements, or how much of that is exposure to sort of like the sort of greasy, smoky air that comes out of this. It looks like the way that it was attached was just with these metal fingers. I've used this style cap in other places, and they never want to stay in place. They always loosen up. And my guess is that this one just loosened up over time and then eventually fell out. And clearly it did not survive the drop down onto the porch. I never really looked at this thing well. I didn't put this in. We had our kitchen remodeled years ago. And that vent over the range never really seemed to move as much air as I would anticipate that it would, based on the size of the vent pipe. So I think we could probably come up with a design that, blocks the outlet a little bit less, because there's no screen in here. Like, it's still open. That gap is still probably an inch there, or at least 3/4 of an inch, but it's only in that ring around. And I guess you get the nice benefit of, if you look straight up at this, you can't see inside the pipe. But honestly, I think I'm more interested in moving, that smoky air from the range out of the kitchen than I am necessarily aesthetics. If I look directly up and I can see into the pipe, if I'm standing like right underneath this, yeah, it doesn't really bother me. It's over from the door far enough that no one ever really sees this. So I definitely do not want to duplicate the way that they attached this. My initial thought is to do a design that has some large threads on the outside. That'll give us a lot more surfaces to grip from, and should even kind of hold in tension a little bit, versus these guys. The way these work, these are kind of holding in tension too, but because there's only 3 of them, I think it can kind of rock out of place a lot easier, which is what I do think ultimately happened with this one. So I'm going to set up a ladder. I'm going to get some measurements out there. And actually, let me grab some. So this is the tool I'm going to use to get the measurement up inside that pipe, because we don't want the measurement down at the bottom where that flange is that this one mounted into. We want the measurement further up, especially if we're going to design something that threads into that space. And this is one of those things, you'll see these at like a yard sale or an estate sale, and it's going to gloss right over it because it's like, oh cool, a relic from 100 years ago. But the reality is, these are still a really great tool for getting inside dimension measurements up inside something, because you open them up and they're nice and stiff, so you can keep opening them up and either slipping them between like 2 flats, or kind of working them around inside of a pipe or of a circular opening until you get like a nice sort of tight scratch fit. And then you take that same sort of like, tight, call it like a scratch fit, where you can feel a little bit of friction but it doesn't bind up, and you just duplicate that same feeling in your calipers, and you end up with a pretty darn accurate measurement that you normally could not get calipers or another measuring device up into. So if you see these, pick them up. All right, and here is the initial design that I came up with to test this. And it's obviously not going to be solid like this at the bottom. I really just want to test to see if the threads are going to work out for this and if they are the right size. I did bother modeling some of the features in that I plan on keeping, like for example, the overall profile and height of this. I put kind of a little cup or relief inside, because I saw that it looks like that ring there comes down a little bit past the bottom of the soffit and has some screws. So I would like for this face to sit all the way up against the soffit material and not actually just kind of be forced down a little bit by that ring that's still up there with those screws. So that should allow clearance for that. And I put just a 3/4 inch square drive here in the bottom, figuring that I can use a 3/4 inch extension and an adapter down to like a 1/2 inch ratchet, just to be able to actually screw this guy into place and then unscrew it as well. Because we don't know if this is going to be too loose, too tight, just perfect. That's probably not going to be just perfect, but yeah, stop talking about it. Let's hit print and let's find out. All right, our test print is completed and came out pretty nice. The threads look really good. This was done at a 0.2 millimeter layer height on my Bambu P1S. The one problem that I'm having well, not only just with this print, but with that machine is either after a recent firmware or slicer update, I'm not sure which one it is, it seems to about half the time grab the purge line off the bed and kind of carry it over to where the print starts. I thought it was the sheet. I cleaned the sheet, regular dish soap and hot water, and it's still doing it. So it seems that there must be some sort of weird issue with either maybe it's not stopping extrusion, maybe it's not retracting, I don't know. Something is causing it to pull that prime line off the bed and drag it over to the start of the print. This is probably the third time I've seen that happen on that machine. Otherwise though, this looks good. All right, so here is a 3/4 inch drive extension. Let's see if this fits. Ooh, that does not want to start. I may have made this too small. I think I made this exactly 0.75 inch. I probably should have left a little clearance. Not sure what I was thinking there. Let's see if we can get this guy jammed in. All right, well, that is way more snug than it should be, but it did go in. So that should allow us to test this by seeing if it will thread in there or if we need to reduce the outside diameter of these threads. All right, let's go test it. Yeah, it seems a little snug. It did start in there. Yeah, actually it might keep going. I'm a little worried about this piece that we're going into is actually plastic as well, and I don't want to crack that. I think we could probably go a little bit smaller with the major diameter on our threads here for a better fit. You know, I just realized there's actually a lot of like pieces of tape and foil and stuff up here. I probably should have cleaned this out first, because that is definitely going to affect our fit. Yeah, whoever put this in, what the heck? Oh, there's like a, oh, that's cute. So it looks like the vent was a little bit short and they just taped a piece of sheet metal in there to make up the gap. All right, I got all the tape out of there, and yeah, I clearly should have spent more time up here before I started designing this. This is why I hate paying people to do stuff for me. Because they do stuff like this and you don't even know about it. And I know this isn't everybody, but this is the company that we contracted to remodel our kitchen years ago. And they did an okay job with the kitchen, but this is not the first time I have found stuff like this after they finished. So, all right, I got to figure out something better here. I did just try our part in this here without the tape on it, and it does go a little bit easier, but it still hangs up and I don't want to crack this ring. So we definitely still have to go smaller on the major diameter of the threads for our vent, but I clearly need to figure out a better way to extend that, or at least use the right tape. All right, I think the term for this is scope creep. All right, the deeper I go, the scarier it gets. When I took a look at this with the ring off the bottom here, I could see that this actually comes at an angle. It's canted off to the side. And I thought I could fix that initially just as easy as cutting the tape for the elbow, straightening it out and taping it back on. But the pipe is rigid mounted far back in there where you can't really see. And they actually cut this hole in the wrong location. So if I fix the angle of the pipe, I would need the hole to be over this way by, probably like 20 millimeters, maybe even a little bit more. That's not going to work. Honestly, it is a bit tempting to just rip all this out and redo it. But I know that that's overkill for this, and I got to get better at the concept of good enough, especially when it's not my own work and I'm just trying to fix it and make it as best as I can. So what I'm thinking is our piece that we made here, that actually fits up inside that pipe. It's snug, but it's not snug enough to grip. Like, I don't have to turn it. I can just shove it up in there, but it's pretty tight. And the soffit is also hanging lower here. I think we can actually kill a couple birds with one stone here. What if we stick with sort of the threaded design? I put some self-tapping screws from the inside out so that the screw heads themselves will act as, call it kind of not a female thread, but it'll give some surface for these threads to grip on. And we designed this with an open bottom. I was originally going to design this with the grill integrated into the part itself. But if we design it as a separate piece, and I can basically screw this up in there and then reach my hand in and seal around the top where this goes into that pipe, because it goes right into an elbow. So if I'd use some like thick aluminum tape to make sure that the air is guided down into this part, and then as a final step I installed the grill on the bottom of this, I think that might get us there. And I say kill two birds with one stone because keeping this threaded, we can also just turn it in until the soffit is pulled up to the right height. So that's what I'm thinking. I'm gonna go see if I have some screws that I can put into the inside of our pipe coming down here. So the heads of one of these, yeah, that should actually work rather nicely. And if you're wondering how I'm going to get these in that tight space, because even my compact head Bosch impact driver is not going to fit up in there, but I picked up one of these a while ago. You know, I hardly ever use this guy. This takes a regular 1/4-inch bit on this side and has a 1/4-inch drive on this side, and just converts the torque there to a right angle in a really tight spot. Now, this is really nice to have. I'll put a link to this down in the description of the video. You're hardly ever going to use a tool like this, but when you do, there's really nothing else that'll work. All right, I got 3 in there, roughly equally spaced apart. I can't see the screen on the camera, so hopefully you guys can see them in there. Let's try it. All right, it does stay up there, but it's still a little bit loose, and I think I can, yeah, if I work it back and forth, I can get it out. I think we might actually be able to solve that by putting a couple more screw heads in there. Let's try that before we do something more drastic. All right, I don't want to talk about how long I've been messing with this, but I have, I think, the right number of screws up there in the metal pipe that we have a good fit on our known thread profile. In fact, it's actually almost getting dark now. But that's a good fit. I could probably hang on this and it's not going to go anywhere. So I think now it's time to just redesign this part to take into consideration our, let's call it new design, with a removable grate down on the bottom and some sort of tool that will allow us to install this, because clearly we can't have a 3/4 square drive hole in the middle of our grate. Even if we did put one there, it's not going to hold up with the grate material. We need something, maybe the keys in the same way the grate does. I'll have to think about that. I'll figure something out. All right, and here is what I hope is our final design on this. And I actually kept the original test piece in here as well, just so you can see some of the differences between the two. First thing you can see, I shortened the overall height. I reached up there with a ruler and just measured up to where the, basically that elbow kind of begins, because we don't want to go past that. So I was able to shorten the overall height. I also added a neck down here at the bottom before the threads start. I mean, there's no purpose to have the threads there, but the reason to specifically remove them was I noticed on the test piece, the threads were interfering with the vinyl soffit material, kind of pulling it up a little bit as it threaded in. So I figured if we put a smooth section on the neck down there, that should eliminate that. I did keep the cup feature kind of down here at the bottom. I didn't make it as deep as our test piece, since we no longer have that ring installed that mounted the original vent cover or cap. So we don't have to clear those screw heads anymore, but I also noticed that some of the cut edges on the vinyl soffit did poke down a little bit. So, I figured if it hides those and we still get a nice flush fit with this face here up against the face of the soffit, that should look good. One of the other changes I made is I have a huge lead-in bevel up here at the top. It's a little bit tricky just to see here in the view in SketchUp, but the reason for that is because I want to make sure that we're guiding as much of the air as we can into our, our adapter or our piece here. So with this bevel and some, thick aluminum tape, I think I should be able to create kind of a nice seal between this, this angled face and the face of the inside of the elbow that this is going up into. Now, this is pictured in here with the grill installed, but we're actually not going to have the grill installed right away. That's going to be with 4 really small, I think M2 by 8 machine screws, if I recall. So this will print as a separate piece. This will get installed last. The first thing that's going to go in here is our install tool. And I stayed with the 3/4 inch drive, but I increased the clearance a little bit here and added a bevel at the bottom. I think I did this at 0.76. So hopefully our 3/4 inch drive extension piece will slide right into this guy. And I might be pushing my luck with these small fingers. Everything looks big here in CAD. I think these are only 5 millimeters across, but there is 4 of them. So I'm hoping that that is strong enough to transfer the torque to install this guy. I don't want to go any bigger because I like sort of the 5mm thickness of the structure of the grate. So I'm going to print this out of the Bambu Lab PETG-HF. The original test piece was done in just plain old scrap PLA. I'm going to do this one in PETG-HF. I think PETG is going to be resilient enough for this application. It's going to have to contend with some heat, but I don't think outside the range that PETG should handle. And I also need resistance against whatever condenses out of that smoke that comes out of the vent from the range hood. So oils, and, just other things that are created while you're cooking. So yeah, I mean, is PETG the right choice? I don't know. I guess we'll find out, but I think it's going to be the right choice to start with. So I'm going to get this sliced up, get it printed out, and I'll bring you guys back. All right, everything completed successfully. And again, these are printed in Bambu Lab PETG-HF, and I printed these on the Bambu Lab X1C, and these two came out really nice and clean. I printed this first, and I didn't touch it. I wanted to show you guys before I did any cleanup on this. This filament was dried. It's possible that it wasn't dried enough, but I don't think moisture is what's causing the sort of stringing or other issues that we're seeing on here. I think it's contamination. If we look inside, you can see there are some black pieces in here, even as far up as, here. I mean, this is close to the top of the print. That's not burned filament. So the last thing I printed on my Bambu Lab X1C was black flexible PLA for the tires on the solar rollers that we did 2 weeks ago, I think. So obviously I backed that filament out with an unload and then loaded the PETG-HF. But you can see all the way up as, well, that one's, this one's attached kind of to the side. And this has some of that black flexible PLA in it. And this is probably, I think this was maybe 280 grams of filament, if I'm not mistaken. So that would have been probably 200 grams of filament flowed through that nozzle, and we were still getting little chunks of flexible PLA, which is why, I often see in the comments when I do multi-material prints on the Bambu Lab H2D, people asking if they can do it on the AMS. And you technically can. The problem is there's really almost no purge value that is going to completely eliminate the contamination. I think we're probably there by the time it hit the top of this and these came out, although even in this one I did notice, there's one little black speck right there. This was the last piece that I printed. And I don't see any black anywhere on this. So I think by the time I got to this print, it probably was fully purged out. But I think you have to consider with dissimilar materials, imagine it like oil and water. They don't stick to each other printed. They don't stick to each other when they're in their semi, molten or plastic state really too well either. So I think a lot of folks imagine when you replace filament and you purge it out with whatever the new filament is, that they kind of mix together and it just clears out. But that's really not the case. Imagine if you filled a glass with, say, oil, and you dumped out the oil, and then you filled it with water, and you dumped out the water. There's still going to be oil coating the sides of that glass because the two don't really mix with each other. Now, eventually, if you just keep refilling that glass with water and dumping it out, just through the mechanical action of filling the glass and dumping it out, you're eventually going to rinse all that oil out of there. But it's going to take a long time. Now, if you filled the glass with something that mixes with water, and then filled it with water and dumped it out, in one shot, you'd have almost all of it out. So that's kind of what's going on inside of the nozzle. So when you switch filament, it often takes quite a while until it gets flushed all the way out. You have like bits of filament, and they'd rather stick to the inside of the nozzle than they would to the other material that's flowing out of the nozzle. And you don't generally have that problem if you're printing the same material. Like if you have a print, say, that's 4 different colors of PLA, and you have 4 different colors in your AMS, generally, as long as you purge a reasonable amount out, and the purge values in Bambu Studio are pretty good, you're fine. All right, I'm going to clean this up off camera now. I just wanted to show you guys the bits of other material so far up on this print. All right, that cleaned up nicely. That should be all set to go. I believe we have some supports to knock out of this guy. So the holes are larger. It's a counter bore up here to accommodate the head of the fastener. Now I could have printed it in this orientation so we didn't have supports there, but I wanted the texture on the bottom of the grill to match the same texture from our part here. So probably not that important. And now I have some supports to remove, but I'm thinking with this little drill bit, these guys should pop right out. Let's use the flat end. Uh-oh. Nope, that one came out. Yeah, they're flying out of there. That one came out easy. That's all four. Yep, looks like they all came out pretty clean. Let's try our fasteners in this. Bet you guys were probably yelling at your screen, especially if you've got a big screen. You probably saw this little bit still hanging in there, even though I didn't, until of course I turned the camera off after just saying they all came out cleanly. This one did not. There's a bit just still hanging on in there. All right, now I think we're good. All right, so this is sized for M2 by 8, the smallest size in the set. And as usual, I'll link this set down in the description of the video. But these guys, M2 is really, really tiny. We shouldn't need that much mechanical holding power for this grill. This thing is super lightweight, even with air pushing on it. One of these screws, from a mechanical perspective, would probably be plenty, but we're gonna have 4. So let's just make sure that these fit. Ooh, the bores are a little tight. Let's see, flip it over, see if the head fits in the counter bore. All right, head fits in the counter bore. Looks like our hole's probably closed up a little bit, so let me get the appropriate size drill bit. We'll just drill them out. All right, so even though this is a metric fastener, I'm gonna measure this in thousandths of an inch because most of my really small drill bits are imperial. And it is 76 thousandths of an inch. So if I take a look at my numbered drill index, it's nice because it gives us the thousandths of an inch down here on the lower part, so you guys can see that. So we were 76 would be the minimum clearance, so we could probably go to maybe 78, which just happens to be a number 47, and that should give us a nice clearance hole for those. Do just one first and check it. Yeah, that's a nice clearance fit now. I guess we probably ought to make sure this does actually fit in here. Yeah, that fits in there just fine. And our install tool, doesn't really matter which way we go in with this. Yeah, that fits as well. Let me grab the extension. Oh, that fits perfect. So I got to remember that. If I ever need to put a 3/4 inch drive into a 3D print, just make it 0.76, and it'll be a nice slip fit. All right, well, I think it's time to head back out onto the porch and try installing this. I'm going to leave the install tool in here because the first thing we're going to have to do is thread this back up into position. And if you remember, we have this nice slope in here on the inside so that I have a nice face to hit with some like thick aluminum tape so that we maximize the amount of air that's flowing into this rather than trying to flow into the threaded area here on the sides. So I'll pull the install tool out to do that so I can reach my whole hand up in there to put the tape in. And then if all goes well, we should be able to put the grill in. I think we can call this done. All right, I think that looks pretty good. I tried to screw it in to the point where it's not pulling up on that soffit material, but it's not letting it hang lower than the surrounding material either. So I think it's time to see if we can get that install tool out of there and get the tape in place. I don't know if the camera is going to focus close enough, but you guys can kind of get an idea what that looks like inside there now. I used a thick aluminum foil-based tape. You generally want to use a foil tape like this for ducts because even if it loses its stickiness, it tends to stay in place anyway, particularly for bends like this because it's thick enough that once it's kind of bent into position, it just wants to stay there. And I feel like I've got a good seal all the way around. So let's put the grate on. All right, well, those little M2 fasteners went in no problem, and I gotta say, I think that looks really great. I mean, I guess I'm biased, it's my design, but I think that looks a lot better than the original vent that was up there. And if this guy gets really dirty, or if it does fail in the future, I mean, I can always print another one. I'm really curious to hear what you guys think, and or what filament you would have used for this. I think PETG is a good choice. Maybe it's not the best choice, but I think it's a good choice. I think it's gonna have enough resistance for heat. I mean, you know, there's probably 8 foot of ducting from the range hood until it actually exits here. So I don't anticipate the air being super hot, but there is going to be a lot of contaminants in it as it is a range hood. So, you know, all that stuff that gets generated when you're cooking, it's going to end up flowing through there. So I'm curious to hear what you guys think down in the comments as to how well this guy's going to hold up and or if there's a different material that you would have chosen. All right, I just went inside and turned this on to the highest setting and it is flowing a ton of air. It never moved this much air through here before. So I think we've also made a significant upgrade in the amount of actual airflow through this guy as well. Well guys, I think we can call that a success. And the only real challenge I had doing the install was, I don't know if you guys caught it or not, but when I had the install tool in there and we were threading it into the pipe, there was one point where it was really, really tight to keep threading it in place. And we had another, you know, call it 10 millimeters to go. And I was a little bit worried that the amount of torque I was applying to the ratchet was greater than the 4 fingers on here were going to withstand. But in reality, we're probably nowhere near the breaking point because these aren't bent or damaged in any fashion. So yeah, it worked out great. And if this is by chance your first time here on the channel, this is all we do. It's all functional printing and, you know, the related engineering that goes along with that. So if you like that sort of thing, check out some of the other videos on the channel. I've got, I think at this point, over 200 functional printing videos. And if you want to see what I'm doing next week, hit the subscribe button. And guys, if you do, I'll see you next Friday.